Welcome back to our channel. This is the first time an object from interstellar space has been observed visiting our solar system. Since humanity began exploring space, we have been trying to discover whether we are alone in the vast universe. The quest to understand our place in the universe has spawned countless missions and research projects. As we gain more knowledge about the planets in our solar system, it becomes clear that there is no obvious presence beyond this planet. The limits of our exploration seem to extend only to the far reaches of our solar system. We have long been on a quest to find answers to the fundamental question of whether life exists elsewhere. Our quest for these answers has continued since our first encounter with an object called the Kaiser telescope. The instrument has once again captured images of and #039 Oumuamua, sparking considerable interest and debate among scientists and the public. MIT physicist Michio Kaku has weighed in on the matter, reporting that and #039 Oumuamua is back and something unusual is happening. Join us as we explore the events surrounding Oumuamua and discover what it all might mean for the future of Earth. If you want to stay up to date with the latest news from the universe and its surroundings, subscribing to our channel can be your gateway to the latest discoveries. Remember to like this video and hit the notification bell to stay updated. In 2017, astronomers made an extraordinary and groundbreaking discovery when they discovered an object called Oumuamua. This discovery was revolutionary not only because of its nature, but also because of the way it reshaped our understanding of celestial bodies. This particular discovery shocked the scientific world because of one important factor. It was the first known interstellar object to pass through our solar system. The implications of this discovery are profound, suggesting that objects from outside our solar system can pass through our cosmic neighborhood. Studying this celestial body from outside our solar system is an unprecedented challenge. New techniques and technologies are needed to analyze an object so different from anything we have observed before. Until the discovery of Oumuamua, astronomers had focused primarily on observing and studying objects within our solar system. This focus has limited our knowledge to a relatively small portion of the universe. However, there are still many unknowns to be resolved in this field, highlighting the limitations of our previous observational capabilities and #039. The appearance of Oumuamua has opened up a new category of exploration that allows researchers to gain information about objects beyond our cosmic neighborhood, thereby expanding our understanding of the universe. IT offers a new perspective that had hardly been considered before, challenging established theories and inspiring new avenues of research. The discovery of Oumuamua is certainly of unprecedented importance, but why do we say so? Its importance lies in the fact that it provides insight into the unknown and raises questions about the nature of interstellar objects. And #039. The Oumuamua expedition has had a significant impact for a number of reasons, including the opportunity to study the diversity and composition of objects in other star systems. The discovery has expanded our view of what is possible for celestial bodies and their behavior, as well as our understanding of how celestial bodies form in the universe, potentially revealing new insights into the conditions under which planetary systems formed. By studying its composition and structure, researchers have sought to decipher clues that reveal the conditions and processes that formed an #039 Oumuamua during its journey through interstellar space. This effort involved analyzing data from a variety of instruments and simulations. The object has an elongated, cigar-shaped shape made of rock, and its aspect ratio distinguishes it from any asteroid or comet observed in our solar system. Its unique form raises questions about the processes that led to its current state and the forces it encountered during its journey. Comets are objects made primarily of ice that form in the outer regions of the solar system, such as the Kuiper Belt or the Oort cloud. These regions are considered the outer limits of our solar system and are home to many icy bodies. They are made up of a mixture of water ice, frozen gases, dust, and rocky material. It is this composition that gives comets their distinctive appearance and behavior. Unlike the unique elongated shape of Oumuamua, comets often have different characteristics in shape and size. In general, comets tend to be more rounded or irregular in shape, influenced by accretion and erosion. As comets approach the sun and heat up, the ice in their cores evaporates, releasing gas and dust particles. This process creates a cloud of gas and dust around the core and sometimes also a tail that extends away from the sun due to solar wind and radiation pressure. The tail is a prominent feature of comets. making them some of the most prominent objects in the night sky. The nucleus, the solid central part of a comet, is typically smaller and denser than hair. However, comets can vary greatly in size. A prominent example is Halley's Comet, which is known to return to the inner solar system every 76 years. This comet has a core about 15 kilometers in diameter, which illustrates the variability in comet size. Some comets can have even larger nuclei, reaching tens of kilometers or more. However, they are largely similar in appearance. What sets Oumuamua apart from these common comets, however, is its red color, reminiscent of objects found in the outer regions of our solar system, suggesting a different composition or history. The red color suggests a unique composition or particular surface features. This distinctive color could indicate a different chemical or mineralogical composition than common comets. Despite being close to the Sun throughout its orbit, Oumuamua shows no signs of a coma, which makes it clear that it is not a common comet but something completely different. The absence of this hair is a key factor in distinguishing Oumuamua from other known comets. One of the most intriguing aspects of and #039 Oumuamua is precisely that it does not fit the model of a conventional comet. Its behavior and characteristics defy our expectations of such objects. And #039 Oumuamua, which originated in the constellation Lyra, entered our solar system, but its exact origin remains unclear. This mystery adds an additional layer of intrigue to the discovery. And #039 Oumuamua's journey into space could have taken billions of years, crisscrossing the galaxy before encountering our solar system. This vast journey suggests a complex history and interactions with different cosmic environments. According to a study published in the journal Nature Astronomy, Oumuamua is likely part of a larger planet in another solar system. This hypothesis implies that Oumuamua could be the remnant of a disturbed celestial system. However, the intense gravity exerted by its host star tore it apart, creating scattered fragments. The forces involved in this process highlight the dramatic events that can shape celestial objects. Its journey through interstellar space began when it was ejected from its home system, putting it on a trajectory that would eventually take it to our solar system. One of the fascinating aspects of Oumuamua's behavior as it passed through our solar system was its sudden acceleration. This acceleration intrigued scientists and led to further research.